Alright, it has been, oh, I don't know if this is, alright, I think it's working now. So it's been a few days, I think 1 day, maybe even 2, 1 day I guess, where I have dealt with this kata. So we are at, there are a bunch of helper methods. Get angle in second quadrant, get angle in third quadrant, get angles, all of them. So we say degrees traversed. This should be in a while loop. All points in second and third quadrant are over there. Copy points at the second. Dictionary of points and angles. Point with lowest angle. Degrees traversed. Oh, and now we need to like switch up. Return point with low get angles. So now it shall be point with lowest angle. Let's see, let's just run it, see what we get. We get a point with lowest angle. Alright. So here we say spin the coordinate system to new center. Alright, and that is okay, want to reattempt. Yes. Now we want to do the third step. Calculate the radius of second circle. Like for each point, calculate the second circle. All right, and that becomes a little bit tricky now, because I think that we have to make where is this? Oh, what did I do? Not this one. Windmill cycle, we can close this one because we're already training on it over here. So we say spin the coordinate center to a new center. Coordinate system to new center. And here we just say what do we return? Here is spin the coordinate system to new center. But here we actually call that function. So we just say get new list, get updated list of points by calling spin the coordinate system to new center. Alright, so we gotta get a couple of them updated points over here. And what do we get? Like def return new set of points. Well, what do we get? What do we need to have? Angle by which it is rotated. Okay, so basically we say alt points rotation angle, alt points rotation angle, and I guess the alt points rotation angle and something else. And the new center point, so that it shall be one of those old points. So what do we do over here is to say, so first we wanna, what do we say, calculate the radius, so see circle, calculate, alright, so then we have so here we say get, so first just rotate points, how do we do that? Well, we first we do what? Damn, I spilled some on my fucking keypad. Now I have to reset the computer or something like that. I mean on the mouse pad, you know. It's pad, it's not mouse, it's mouse pad. Alright, all changes saved. Nice. So we get that by so we calculate the radius of the circle. So we say calculate the distance of points from the center. That's way. So you say now we have the equation of circle on which they lie. What's them? They all tell lie. Alright, so then we say C. So now we gotta get the length based, but that is the that's the, because we could just as well get, instead of calculating this circle, we well know the name of this angle, but let's just do circle, you know, what the hell. So first you gotta do tetiva. Yeah, it's called this tetiva in oops, not in Espanol, but in English. A red segment is a chord. We need to calculate the chord. The chord of the chord of the circle in our case. Alright, so we say training. Now we have the equation of circle of which they lie. based on the, well, what do we need for the chord? We need that. Oh, that's CRD were used. All right. So for now we just say calculate the chord. The chord of, let's say chord on, say the chord is a circle in a straight line segment whose end points both lie on a circular arc. And our chord is which is the side of a triangle and a Kokraki triangle. So I say that's the AB, where A is B, isosceles triangle. So we say calculate the chord which is the bottom line of the isosceles. I want to hear the pronunciation.
Isosceles.
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 Isosceles. Isosceles triangle. Thank you, Merriam-Webster. Calculate which is the bottom line of the isosceles triangle with the, so what is the name of that point with its top angle known. Triangle, but we basically know all of them angles. If we know one top, we know them all. If we know one angle in the isosceles triangle, we know them all. And I have to go to the toilet to start thinking. Alright, so I'm back. And now where were we? So we say calculate the chord which is the bottom line of the isosceles triangle. Get a new get the second circle equation from chord length and the point center of circle points coordinates. Alright, now find where first circle. Alright, so find where find where first circle is overlapping second circle, like we get 2 points, as you can see, 1 2 1 2, and so we say then pick the right point. So we say or return the right point. So if the original point is in quadrants if the original point is in quadrants 2 or 3, return the point with the biggest y value. So of this and that, we're rotating in this way, right? Now we're rotating in that way. Damn. Yeah, we're rotating in that way. I think I have made a mistake before. I think we need to rotate, because I think this is like a message. Yeah, we need to put C over here. So that would mean that the C has less x value from B, but actually should have more x value than B. So we say we do that. We find the one with the lower, with the lowest y value. Is that right? Yeah. Huh. Is that true? Is that true? If P is over there and it's under, yeah, so C. Should it really be rotated even? Oh, Jesus Christ, so complex. Oh, but because B goes over there, C should go over here. With the highest y value, but if it is on the quadrants here or here, it's that circle. And if it's in quadrants, it should lower y. So or if it is in quadrants 1 or 4, it is the one with lower y value. So that we have the point. Alright, oops. Return. Now we rotated points. This is needs to be figured out, and also this needs to be figured out. Maybe it's better that we do this in our local environment, because this can become really hard to troubleshoot, if you know what I mean. So now we have rotated points. Now we'll say move points and so we need to lower, so we'll say new center point. So you say now the center point's coordinates should be like x should be 0 and y should be something. So like reduce, like, so y is y always positive is the question. Y should, I think, always be positive. Reduce the y value of all points, including the new center and old center, by the y value of the new center. So at that point, I should say the new center point should now be at 0, 0, 0. Should now be at 0, 0. So that should be at 0, 0. And what else? So new center point should be at 0, 0. So here we shall say return the set of new points. Get updated by calling, and then this should be then done again and again, and here we shall say return the number of cumulative hits. Alright, quite a lot, I agree. Let's have a pause. Alright, so we shall say rotate points. So I just say rotate point. So we shall say 4 point in old points. This should not fail, right? 77 expected an indented block. It's not even called, so we say for pointing points, calculate the distance of points from the center. So how do we do that? Calculate the distance from the center. It's very easy, because we have the point, so we say distance from center equals to say xy is point. So here we say distance from center is x. Everything that is square rooted. So we say x times x plus y times y, classic Pythagoras. So here we just say print for point the distance from center is distance from center. All right. Turn it. All right. So here's new set. New list of points is return new set of points is return new set of points. We needed a list of points. We need the angle, right? Rotation angle. So we say decrease traversed point with the lowest angle. Say point with the lowest angle. That's what? 1, I guess. And new center point is, I guess, point with the lowest angle 0th thingy. I hope. Point with the lowest. Oh, without the. I think that I made that mistake before, where I included the, where I really shouldn't include the. Distance is 0 for point 1. Alright. Well, but is it 1? I mean, that's really fishy. What's the Pythagoras for like 1, man? Because are you telling me that, like, if this is 1, that from here to here and from here to there it's the same? It's not the same. Oh man, like, why didn't I think about that before? I was like learning this fucking shit in school for 11 years at least. No, for 13 years and even more. And now I cannot realize what's wrong with this application of Pythagoras theorem. A na kvadrat plus b na kvadrat je c na kvadrat. A na kvadrat plus b na kvadrat je c na kvadrat. C je korenjeno a na kvadrat plus b na kvadrat. 1 plus 1 je 2. Korenjeno. Alright, yeah, I get it. The distance from center, yeah, this is wrong. Oh, 1 0. Oh, it's 1 0, not 1 1. Okay. Alright, acceptable. 2 something, 2 something. So this and that should be, like, all of them should be the same, and they are. So that's great. We got the distance from the center. Really cool. For pointing all points, for each point, calculate the distance from the center. Now we have the equation of the circle. All right. Calculate the chord. Okay. Calculate the chord. How do we calculate the chord? Is the bottom. Alright. So we say here, what is this? Red segment is the fucking shit. Is ellipse, fucking circle, and it's R. Radius. Alright, so here we say radius of second circle, and we say that radius of second circle, aka, let's just write it here, this is radius from first circle, and the radius of second circle is what? The radius of second circle is what do we call it? Calculate length of chord. What do we input? We input angle, and we input side. Because now, alright, let's make a, I guess we need the, oh, this is the same. We need a new one. Because right now, let's say we got this angle, so what we must figure out, let's draw. You got this isosceles triangle. Something else. Something else. Yeah. Isosceles. Say isosceles. Yeah. So you got that. Fuck. I just use. It will be much neater. Line. Oh my god. No. Move that. Move that. Move like so. To move like so. Done. So we know. What do we know? We know this line. This thing we know, and consequently we know all circles, which is basically the same, so we can say beta. Okay. Have some water. Alright, it's actually possible now. Let's have a stretch also, why not? So that's beta. and this here is also beta, and we know this, and we know this, so only this is the question. Oh, all right. Now, yeah, it should be really simple to calculate this one. I circle this triangle height. We're not really interested in height. Area, perimeter. If we would have perimeter, that in the area T and perimeter are related. But what is the area T? You know. Angle bisector length. If the two sides radii AB for H scrap square it's working class. Apex. All right. Let's jump back to Slovenian. So you got height. It is, yeah, alright, this is the angles, this is the height, which we need C, because we're basically interested in C, which we need C to find out. That ain't helping. Polovični obseg is 2a, so 2a plus c divided by 2, that's half. Heronova formula. Oh, this is Hero. Yeah. He said 1/4 2a plus c is c for, yeah, in all of them we need a and c. So we can, I guess, solve that using trigonometry. This is the right triangle. I guess we could use the trigonometry again, the cosine rule. A law of cosines. And we say basically that would translate here as AA. So this, let's call this B. So you say B squared is B squared is A squared plus A squared. So we're interested in that. We must do that plus that minus 2 times a squared, I guess. Shit. And so that minus 2 times that times the cosine of this angle. So we say times the cosine of alpha. Okay, I guess we shall import this. So alright, so here let's say calculate length of chord. So here we say define calculate length of chord. What do we get inside? Angle side. And here we just return square root of side times side plus side times side minus 2 times side times side times cosinus angle side times side plus side times side minus 2 times so that is basically 2 times so that should be a negative number. Oh no, it won't, because it is multiplied by cosine right over here. So here we can just say, instead of that, we say that's 2 times, so we say 2 times that, and cosine of angle, I guess it will be less than 0. So say Python math let's see, trigonometry, a logarithmic function, trigonometry, return the arc cosine, return the cosine of x radians, but that's in radians. So I guess we have to like change that also to degrees in there, degrees and radians. So we say cos angle and we radians. Well, change it to radians, and we also like need to get it cosine thingy and going on over there and going on over there. Return the cosine of x radians. Radians x. Radians cosine of the angle. Is that right? So let's see. Let's print out radius of second circle. Oh. Oh. Who? Name angle is not defined. Oh, rotation. It's rotation angle. Rotation separation, rotation, that's a Dutch angle, rotation angle. Name side is not defined. Side is actually distance from center. Alright. We said we want to print that out here. So the radius of that circle is, I guess, that's always the same over here. Here it's more than 1. Yeah, we can test it rather quickly. So we say we got point over here, and we're basically for 90 degrees, and that should be, so you got it here, that should be really more than 1, and I guess this is just like, if I understand correctly, with calculator, that's that on 2, that's 1.41, yeah, so. Alright, so we got the radius of the 7th circle. Now calculate the chord, which is the bottom line of the isosceles. This needs to be figured out, and it has been, you know, good thing to congratulate ourselves. Get the 2nd circle equation from the chord length. Find where first circle is overlapping the 2nd circle. So now we have 2 equations which should look something like, oh my god, I really need a mouse. Provам на ролко. Нека зрачунам да не гре. Ай не е да. Ще пенди да гледам. Кога ще ти больше долу? Ще ти больше долу. Не, чорт на концерту. Какой добър гър.
Eres.
Ovo te mani su se voda naprijed, Azija po
Ja sam mislila.
Hoćeš reći da nije ideš na bene mandarine? Torej sem jaz zdaj cel cajt snemal, ker sem mime gledal.